Hello my dear JEE and NEET aspirants. I welcome you to NEET World. So today we will be discussing the topmost important questions of GOC, General Organic Chemistry, that must be solved by every aspirant. Okay, so in order to check whether you are clear with the concepts or not, you have to solve these questions at any cost, because these are the very important or very conceptual questions. Look at here, I have a first question here saying that which are the following double bond in the given molecule is most reactive towards a strong protic acid. See, so in order to answer this, you need to know the stability of the given respect to carbocation formed from this after adding H plus ion. So to this, let me change the color of these pens. Yeah. So yeah. So to this compound, we need to add H plus ion. So where we can add this H plus ion? They are saying protic acid. So A, B, C, D are the reactive sites they mentioned. So we need to add one of its position. So now hello. Yeah. So sorry guys, there is a technical issue here. So now let's continue our discussion here. The first question here we have is, which are the following double bond in the given molecule is most reactive towards strong protic acid? So just take this particular molecule and treat it with H plus ion. So this H plus ion added to which of these sites, which of these ABC reactive sites? So we need to identify that. So it is very easy, just look at the concept. See here, so if we add this H plus ion to any of these double bond, is pi bond is nothing but the electrons only now. So that electrons will accept this H plus ion. So after accepting the H plus ion, we should get a more stable carbocation. What is this carbocation stability order? So if we have a primary carbocation and secondary carbocation, tertiary carbocation, which is more stable? The tertiary carbocation is more stable right now. So it means after adding these, we should get a more stable carbocation. That should be a tertiary carbocation that can be stabilized by hyperconjugation. See here, if I add H plus to this double bond, it means at this position our positive charge will be on this A carbon right now. So now this carbon is a tertiary carbon which can be stabilized by the methyl group hydrogen alpha. 3 alpha hydrogens are there now. If this is the carbocation generated there, so methyl group is there like this, and we have this side 2 hydrogens are there, and this side also we have double bond here right now. So like this we have cyclopentyl ring right now. So that can be stabilized by this conjugation of pi electrons right now. This is what mesomeric effect plus M effect we can say. And to this, here we have alpha carbons which are having 2 hydrogens here, 3 hydrogens here. So it means there are 5 alpha hydrogens, it can be stabilized by 5 hyperconjugative structures by 5 alpha hydrogens right now. So that is why this A carbon is more, the double bond at A position is more reactive when we compare with others. See, if I react with this C, we are going to get a secondary carbocation right now. Okay, the secondary carbocations are less stable than the tertiary right now. If you stabilize, if you add this here, you are going to get H plus ion on this methyl, which is a tertiary carbocation, but there is no conjugation, there is no mesomeric effect along with this hyperconjugation. Okay, so it means more the number of effects, like more the plus M effect, more the number of alpha hydrogens, that is more hyperconjugation, and also methyl group is there, it means there is plus I effect also. These 3 effects are stabilizing the given carbocation. That's why it is more stabilized, that's why A is more reactive here. So which is more reactive here? A double bond A is more reactive. Hope it is clear. Right. You can write in the comment box if you have any confusions here. Yeah, if any confusions are there, please feel free to express here in the chat box. Yeah, next here we have one more question. Among the following, the correct order of reactivity of chloride ion is. So tell me which chloride ion is more reactive out of these 3. Okay, chloride, which chloride is more reactive in these 3 compounds. See here, whenever you have something like this, organic compounds are there, we know based on the electronegativity difference between carbon and chlorine, carbon is having less electronegative than chlorine, therefore chlorine will take the bonded electrons with itself right now. So now our carbon is getting positive charge right now. So in all these species, after removing chloride ion, we are going to get a carbon on this carbocation on each of these carbons. All of them are having no positive charge right now, electrophilic centers now. So now which carbocation is more stable in these 3? So which carbocation is more stable, tell me, in these 3? See, after removing chloride ion, we are getting a carbocation like this in the first case right now. In this second case, you have something like this. In the second case, you have something like this. In this third case, you have something like this. Right? So out of these 3 carbocations, after removing chloride ion, which one is more stable here? Which one is more stable carbocation? Someone in the comment box saying that it is 2, option 2. Yes, let us verify this option. Okay, see, now here we have double bonds, 2 double bonds with positive charge. If you observe, by looking like this, molecule may be representing like it can be stabilized by 2 pi bonds by conjugation, but the respective compound is anti-aromatic right now. See, anti-aromatic compounds are highly unstable due to the pi electrons are present in anti-bonding orbitals. So this is anti-aromatic compound which is least stable. Okay, here we have a conjugation system like this. So this conjugation, I can say this is a allylic carbocation that can be stabilized by resonance right now. So it means this is more stable, and here there is no conjugation, but you have alpha hydrogens this side and as well as this side right now. So it can be stabilized with 4 alpha hydrogens, 4 hyperconjugations are possible. So which is more stable? So allylic is more stable, then this one normal hyperconjugation, then this one. So what I can say, 2 is more stable, after that 3, and least stable is 1. So where do I 2, 3, 1. So 2, 3, 1. So fourth option will be your perfect answer for this question. Okay. So someone in the comment box saying that second option. No dear. This is fourth option is perfect answer. Okay. Hope this is clear. So why first option is not second option or first option not the correct one? Yes. I am fine here. I hope you are also fine in the chat box. Ajay, your name is also Ajay, right? Yeah. So 2, 3, 1 will be the perfect answer. Yes. Hope this is clear. Let us move forward with few more questions. Yes, you are correct. Yeah. So now tell me, which of the following has highest enol content? Yes, very easy. I hope you know about tautomerism. What do we mean by tautomerism? See, whenever we have a ketone like this, let us say here I have a double bond O here, so I can say this is a ketone, cyclohexanone, right now. So now one of the alpha hydrogen from this side or from this side will be giving its sigma electrons to this carbon, and the pi electrons of oxygen will be shifted towards oxygen. Okay, so now what we are going to get from here, so we have something like this. Okay, so if it is shifting, you are going to get a double bond here and it will be converting into OH like this. So this is keto form, and this one is having one ene, double bond is there now, so alkene, ene, and one OH group is there, ol, alcohol, ol, right, enol, so keto, enol. So this kind of transformation is called keto-enol tautomerism. Okay, so highest enol content. So by this concept you can write keto like enol forms of all these structures, so that you will get a more stable compound. If you are getting more stable compound in the enol form, that will be having highest enol content right now. So now if you write keto enol form from this given ketone, so what you are going to get here? Okay, so let me check in the comment box. Aniradha, so just mention your answer in the comment box. I am looking into it. Yeah, so tell me here, see we have double bond O now, so what happens is this alpha hydrogens here we have as well as here we have. So one of this alpha hydrogen can be converted into enol by shifting, see I can number this as, see 1, 2, 3, so from third position the hydrogen is shifting to first position. So 1, 3 proton transfer I can say, see from third position to first position proton is transferred. 1, 3 proton transfer is also considered as tautomerism. So here again from this like this hydrogen from this third position to 1, so it is transferring to first position. So I can write this double bond O as it is, and here we have OH and here we have a double bond like this. So this is what we are going to get if you write the enol form of this given compound. Like this, if you write for all of these, see the third one will be having highest enol content. Why? Because to this I am considering this is alpha, and to this I am considering this is alpha, to this I am considering this as alpha. So now what you are going to get? You are going to get a double bond between these, and this converts into OH. Similarly this side also you are going to get a double bond here, and this will be converts into OH, and here also double bond here and OH here. See, this is something like phenol, like derivatives of like phenol. Like this we have benzene we have with 3 OH groups, 1, 3, 5 like benzene like phenol 1, 2 diol, right now 1, like see 1, 2, 3, 4, 5, 6. So what we have at 1, 3, 5 position we have 3 like hydroxy groups. Right now it is like a phenol or its derivative right now. So now it is what? It is having more stability, so therefore it will be having highest enol content. So what is your answer for this question? Third option will be your perfect answer here. Okay, yes. Anyone in the comment box? Yeah, so someone is asking, sir, you teach physical chemistry? Yes, you just go through the playlist and check. There are many chapters, there are many sessions I have taken in physical chemistry as well as inorganic along with this organic. Just go through the playlist of this channel, and if you are new to this channel, click on the subscribe button so that you will get daily updates from us. Okay, yes, let us move forward. I hope you got why I am saying 3 is an answer, because it is having like phenolic structure which is more stable. Okay, yeah, whereas this one is having, these are the alpha hydrogens now. Yes, so you just have one OH group, okay, and one double bond here and like this. Okay, yeah, you can write for this one also, but highest enol content is for option number 3. Okay, next look at here, I have brought one JEE advanced question. Okay, very easy it is. Just look here. PQRS are the aromatic compounds. See, among the PQRS, the aromatic compounds is or are. So we can get product PQRS in the given reactions. So whether they are aromatic or not, that is what we need to check here. Okay, so anyone in the chat box can answer this. How can we look into it? See, AlCl3 is a Lewis acid, so that can take lone pair of electrons from this chloride. So these lone pairs can be given to aluminum, so that will be converts into AlCl4 minus. Okay, we know chloride ion is more electronegative than carbon, so chloride ion will take this, chlorine will take this sigma electrons to it. So carbon should get what charge here? Positive charge, right now. So you can have a double bond here, a positive charge here, like this. So this is our P. Okay, so now tell me whether P is aromatic or not. Yes, this is aromatic. Why it is aromatic? See, it has 2 pi electrons, okay, and this can be in conjugation with this positive charge, which is a continuous conjugation, I can say, right now. Yes, so this 2 pi electrons is nothing but it is a Huckel number only, so it should contain 2 pi electrons, and the compound is a cyclic. All the carbons are sp2 right now. So based on the conditions of aromaticity, there are 4 conditions. That 4 conditions are satisfied by this compound, therefore I can say this is an aromatic compound. So what is that 4 conditions? Compound should be, first of all, it should be a cyclic, then next it should be have planar structure. All the carbons should be either sp or sp2 hybridization, and continuous conjugation should be there. Yes, continuous conjugation also there. Yeah, so yeah, that's it. So these are the things should be satisfied. Yes, it is satisfying, having like 4n plus 2 pi electrons. Okay, n value you can put just 1, 2, 3, 4 like that, 0, 1, 2, 3 you put. So if you put 0, you have 2 pi electrons, therefore it is aromatic, like that. Similarly, we have sodium hydride. So hydride means negative charge now. See, these protons are there here. These are acidic protons that can be taken by this hydride ion, so that you are going to get something like this. Like this, and H2 gas is released here. See, this compound is again, what is this compound Q here? So this is also aromatic. How I am saying this is an aromatic compound? Just look at here. Here it is having cyclic geometry, like cyclic structure, and compound is planar by 6 pi electrons like this, right now. So 6 pi electrons are there like this. See, see, now this negative charge can shift here, so the pi electrons will shift here, like that. You have a continuous conjugation in the given compound. So Q is also what? Aromatic compound. Okay, now look at this R. So if you look for R, you have some like dione. So dione you have here diketone. Okay, so what you can do is you just take here ammonium carbonate we have now, so it means it is NH4 plus. This is a salt right now. So from that I am taking cationic part, NH4 plus. So this oxygen and 2 hydrogen from here, out of 4 I am removing 2. So therefore you are going to get something like this, double bond NH2 and plus charge on this nitrogen, like imine right now. So imine is formed. Here you have alpha hydrogens now with respect to this carbon. Okay, with respect to this carbon, here you have alpha hydrogens. So now they can do tautomerism like this. Okay, so you are going to get a double bond here like this, and NH2, and this side double bond O. Okay, so after this what you can expect? Again, see, they mentioned high temperature. So water elimination takes place, dehydration takes place 100 degrees or more than that is it is mentioned. Again, remove water from here, you are going to get a closed ring now. So what is that closed ring you are going to get here? So nitrogen like this, double bond. Again, nitrogen having 4 bonds here. Okay, so here what happens is, again, so here what happens again, so you can have like this we have now. So what happens here is one hydrogen from here will participate in tautomerism like this. So this double bond will shift here. So what you are going to get? You are going to get a pyrrole here. What is that product formed here? Pyrrole, like nitrogen here, hydrogen here, double bond like this. Like this. So what is this? It is a pyrrole. Pyrrole is what? One of the very good example of aromatic compound. Okay, so this is an example of aromatic compound right now. So pyrrole and this one are aromatic only. Furan. So this R is what is now? What is the product R here? It is a pyrrole, which is a aromatic compound. So P, Q, R are the aromatic compounds. Now even this compound is also aromatic. See, this one, when you add H plus ion, that will be taken by the lone pair electrons of oxygen, so that it will be creating carbon with a positive charge like this. here the double bond will be moves towards oxygen side, so that you are going to get like this, and positive charge on this carbon. So what it is? So it is also having 6 pi electron cyclic compound, everything is satisfied aromatic rules. So this is also aromatic. So all 4 products which are formed in the given reaction, so all PQRS, all of them are what? Aromatic only. Okay, I hope this is clear, right? So if it is clear, just tell me that sir it is clear. This is a JEE advanced question, you have multi-selective type, your answer should be more than one type. Okay, so all PQRS, all of them are what now? Are aromatic only. Okay, next here, arrange this one also. Arrange the following labeled hydrogen in the decreasing order of acidity. So which is more acidic? Tell me. Always remember carboxylic acids are more acidic than any of the aromatic sites, like organic compound, organic acidic natures. Like phenol, if you compare with a carboxylic acid only like acidic, and if you compare with alkanes, here also carboxylic acids only acidic. So I can say HB is highest in acidic nature. Okay, then next, which is the next one here, we can say this is more acidic. HB is more acidic, I am saying right now. So write it as HB is more acidic. Then next, here we have OH, like phenol we have, and here we have alkyne. So which is more acidic? Phenols are more acidic than these alkynes, because see, this acidic hydrogen is attached to the oxygen atom, and here it is just to the carbon atom. So electronegativity is more for oxygen. Therefore what it will do? It will easily drag the sigma bond electrons towards itself and releases H plus ion easily. And here you have one strong electron withdrawing group at para position of this OH, which make the phenol to be more acidic now. Acidic nature of phenols will be increases by electron withdrawing groups at ortho and para positions. Okay, that's why this HC is more acidic. After that, this is also like a phenol. On benzene ring you have OH group, means phenol. So after that, HD, and the least is what? HA. So where do we have this option? B, C, D, A. So your first option will be perfect answer for this question. Hope this is also clear. So dear students, try to solve these questions. These are very, very conceptual, and you can learn the real concept from this kind of questions. Do not stick only to the very basic level questions. When you are doing some questions, okay, first of all you try some basic. Once after you got some confidence, just go through some PYQs or some standard questions. Okay, so otherwise you just ask your mentor or your teacher to provide some standard questions when you got confidence in that particular concept. Okay, yeah, because we have seen the last year scenarios for NEET exam, how we have seen the paper level right now. So there are some changes, so you can expect that will be in the same manner or something different in the upcoming exams also, whether NEET, JEE or EAPCET, whatever the entrance exam it may be. Okay, now look at here. Arrange the following correctly represents the stability order of reactive intermediates. So now tell me whether this is correct or not. This is also multiple selective type question, MSQ type question. So tell me, so whether this carbocation is more stable or this carbocation is more stable. So look at here, you have to write this one MOCH2 like this. See, here you have a carbocation, vacant p orbital is there here. To this, the lone pair electrons of oxygen will be donated. So I can say this is resonance effect or mesomeric effect is present, and here we have hyperconjugation by these 3 alpha hydrogens. So which effect is more dominating? Mesomeric effect or resonance effect is more dominating now. So that's why this order is correct only, because it can be more stabilized by the lone pair electrons of oxygen. Okay, so one is correct. Then next, if you look for the second option, see, the pi electrons here are at alternative position with this vacant orbital carbocation, that can be stabilized by this conjugation of the pi electrons like this. Okay, like this. And you know, here we have methyl group this side, which is alpha carbon to this carbocation, that can be stabilized by these 3 alpha hydrogens. Okay, you have both mesomeric effect, I mean conjugation, and also hyperconjugation right now. So these 2 are there that can be stabilized more, and here see the positive charge is present on the double bonded carbon. The positive charge on double bonded carbon is highly unstable. You should call those species as those kind of species as vinyl carbons. What is that? Vinyl carbons or vinyl carbocation here. with positive charge carbocation, with negative charge vinyl carbene anion, like that. So out of these two, always remember allylic carbocations and allylic carbene anions are more stable when we compare with the respect to vinylic carbocations and vinylic carbene anions. So this will be more stable than the first one. So this is also perfectly correct, both are correct. Next, look at here. So what they are saying here, see, in this case the negative charge is there. In order to stabilize this negative charge, what we required, so that negative charge has to be dragged into the ring, okay. So if that negative charge is taken into the ring, then that carbon, whatever the carbon with charge is there, that will be stabilized. Right now it means that dragging, that negative charge can be dragged inside, when it will be dragged inside more effectively when we have electron withdrawing group on benzene ring at para or ortho position. See here at para position we have electron withdrawing nitro group, so that will drag this negative charge effectively, okay, and stabilizes this benzyl carbene anion, okay. So since electron withdrawing group is there, electron withdrawing group will stabilize this carbene anion more effectively than this electron releasing group, okay. So electron releasing groups decreases the stability of carbene anions and increases stability of carbocations. So third option is also correct because it is a negative charge stabilized by electron withdrawing group, okay. Yes. Next here, look at these things. See, carbocations are given. So to this carbocation we have alpha carbons here, alpha, adjacent carbon is called alpha. So if on alpha hydrogens carbon we have 3, 3, 2. So total 6, 7, 8 hydrogens are there. So how many? 8 alpha hydrogens are there. So that alpha hydrogens will stabilize this carbocation by hyperconjugation, okay. So this will be more stable because here only 3 alpha hydrogens are there. More the number of alpha hydrogens, more is the stability. So fourth one is also correct. So all the options are correct here in the given question, okay. So this is also JEE advanced level question, but you can relate it to JEE mains or even NEET also, because the concepts you are studying here are very basic right now. So whether you may be writing NEET or JEE, this will be useful, right? Yeah. Let us move forward with few more examples. Look at here. So which of the following carbocation is more stable? So tell me which is more stable out of these 4 options. Tell me which is more stable. So tell me which is more stable here. See, again these are also carbocation sites. So these carbocations are stabilized by resonance, like conjugation, if any pi electrons are there beside that. So that can be in conjugative position, will be stabilized right now. See here we have alternate position like carbocation, pi electron. So this can be shifted like this, so it will be stabilized. Again positive charge will be here now. This can be stabilized by shifting this one here. Now positive charge will be here. So this can be again stabilized by lone pair electrons of this oxygen like this right now. So now this many times it is stabilizing, but in other cases let us check here. See, now it can be stabilized here one time. Now positive charge will be here. Now this can be stabilized again, this is second time, positive charge will be here. So this will be stabilized by 2 conjugations like this one and this one, okay. But here 1, 2, 3, so 3 times, and here it can be stabilized by only one time, like conjugation will be only once. Positive charge will be here. This cannot be stabilized by any of this conjugation right now, because this is not at alternate position, this is somewhere differ by 2 sigma bonds, but here they are differ by only 1 sigma bond. See how many sigma bonds are there between the 2 conjugative positions? Only 1 sigma bond. Here also only 1 sigma bond, like alternate position should be arranged, okay. So here it will be one time. Now here also you can check, this is also stabilized by one time like this, then you are going to get a positive charge here. So now based on this understanding, where we have more number of resonating structures, tell me. So in the fourth case now, so in the fourth option you have more number of resonating structures, more, and it is continuous right now. Therefore which is more stable? Option D will be a more stable carbocation in the given 4 options. See, again this is a JEE main question, okay. Yes. Let us move forward with few more questions. Yeah, look at here, consider the 3 resonating structures. Consider the 3 resonating structures from the following and correct order of their stabilities. So always remember, whenever you are discussing about resonating structures, whenever you are defining resonating structure stability, look, more the number of covalent bonds, more is the stability of that compound. See, there is no charge in the second compound, only covalent bonds and lone pair electrons are there, so that will be more stable. And after this, so next, here you have 1 and 3. In this case, how you can say, in 1 and 3, how can you decide? So now, more electronegative atoms should contain negative charge, and more electronegative atoms should have negative charge, and the others should contain positive charge. Okay, like this. Okay, and never two like charges should never be side to each other. They should be as far as possible. Okay, like charges should be as far as possible. Okay, now look at here. Oxygen is electronegative, it is having negative charge. Carbon is less electronegative than the oxygen, so it is having positive charge. That is fine, but here if you observe, oxygen is having positive charge. More electronegative atom with positive charge is unstable. Therefore, third one is least stable. Here I am writing. So in between this, we can get second option. Okay. So 2, 1, 3. So 2, 1, 3. Where do we have 2, 1, 3? Option number 1 or option A is your perfect answer for this question. Hope this is also clear. Right. So if you guys are new to this channel, just click on the subscribe button, and if the explanation is clear, you can click on the like button. Yeah, and you can feel free to ask me your doubts, your concerns, or your feedback in the chat box. You can express your feedback in the chat box. Okay, even if you want me to repeat the same thing, I am ready to repeat that. So just write in the chat box. You just connect with your teacher whenever you are in the class. Whoever may be the teacher, just try to connect with them all the times. Okay, yes. Next, here we have one more question. Which are the following is not stabilized by hyperconjugation? Tell me which is not stabilized by hyperconjugation. Yeah, see here, in order to show hyperconjugation, so to the system, you should have, if I talking about carbocation, to this carbocation there should be at least one alpha carbon. On that alpha carbon there should be at least one alpha hydrogen like this. Okay, so then only you can expect the hyperconjugation is to be possible here. So because with respect to this alpha hydrogen and alpha carbon sigma bond, it can be shifted into this vacant orbital of carbon. So what is the mandatory condition? There should be at least one alpha hydrogen in order to show hyperconjugation structure. See, this is a methyl group. There is no other directly attached carbon to have that alpha hydrogen. So hyperconjugation is not possible in this case. Okay, they are also asking not stabilized. Yes, first structure is not stabilized by hyperconjugation. Okay, yes. Next one, here in 2, 3, 4, how can you answer? See here also, if you see, this is a carbocation having 3 alpha hydrogens, and this side is 1 alpha hydrogen. Yes, now it can be stabilized by hyperconjugation of these alpha carbons. Right now, yes, this is perfectly correct. Right. Next, look at here. So in this case, here alpha hydrogens are there, so hyperconjugation is possible. They are asking not possible. Yes, it is possible. It is not possible in this first case, possible in the third case, and it is also, look at here. Do you have, this is alpha, this is a carbocation. To the adjacent side carbon is called alpha carbon. So do we have any alpha hydrogens here? See this carbon, 1 bond, 2 bond, 3 bonds, and 4th bond. Yes, we have one CH sigma alpha carbon hydrogen bond is there, that can be shifted here. So hyperconjugation may be possible here. Okay, yeah. In this 4th case, look at here. So you have this carbon, this is a carbocation to be stabilized. Adjacent carbons are alpha carbons, but there is no alpha hydrogen because all of them are occupied by methyl groups. So alpha carbon is there, but alpha hydrogen is not there. Therefore hyperconjugation is not possible in 4th case also. You can say 1 and 4 will be your answers for this particular question. Okay, yes. Is that clear? So Viggu in the comment box or in the chat box, you are saying octet more stable than ene, more stable than charge. Yes, your answer is also correct for the previous question. Order of stability, yes, follow the octet rule. okay, having more number of covalent bonds, okay, and charge is the least scenario here, and in the case of charge, no two like charges should be beside each other. Yeah, that is also correct. In the comment box, whatever you have written, it is correct only. Yes, let us move forward with few more questions. Yeah, so tell me the resonating structures that is not correct in the given 4 options. So tell me which is not correct. Which is not correct? See, based on the 4 statements which I have given. See, in the first case itself, you can see 2 like charges are side to each other, which is not correct, which is highly unstable. Okay, so you should at least mention that as like a pi bond like this, instead of mentioning it with positive charge, you just make a bond between negative and positive charge, so that will be stabilized. But here 2 like charges are kept beside, so which means this is not correct one. You should choose that as your answer. And if you look for this second question, see, positive charge, negative charge separated by pi bond, again negative charge, positive charge, this is okay. When we compare with the first option, second one is okay, there is no issue with that. So like that, there is no 2 same charges should be side to each other. Okay, based on this statement, no 2 like charges should be side to each other, beside to each other, then it will become highly unstable. Okay, so first option will be your answer for this question. Next, so correct order of stability of the following alkoxides. So how can you write this stability of alkoxide ion? Yeah, Vigo, I think you are new to this channel first. So just first click on the subscribe button and then next go through the playlist of this channel. I have explained these 3 things, hyperconjugation, mesomeric effect as well as inductive effect very clearly. Just go through the playlist of this channel, okay, so you can learn them very effectively with including questions. Okay, just go through that. Okay, yes. Next, here which of the stability, correct, give the stability order of these 3 things. See, I told you, always remember, just check for mesomeric effect first, next hyperconjugation, next inductive effect in case of stability of carbocations, like that we discussed. Again, in case of anions, check for mesomeric effect. Now which mesomeric effect? Minus M effect should be there in the case of carbon anions, because that negative charge should be dragging towards that particular elements. Like if nitro group is there, this nitro group should drag that negative charge towards themselves, because negative charge should not present on one atom. If it is presenting on one atom, that will become unstable. So now how it can be stabilized? If this species will drag towards themselves, it will be more stabilized. Now how it can be possible? See, now negative charge will be given to this carbon, and now these pi electrons will to shift here. So one resonating structure you can expect. Again, after getting here, again that negative charge will be taken towards this nitro group. It is a continuous conjugation here in the first case, in this case, C case. But here if you observe, this can be taken by this conjugation is with this pi electrons like this. Nitro group is not involving in the conjugation right now. So this is no continuous conjugation. Conjugation is there but not a continuous one right now. So this is what you need to look here. And in this case there is no conjugation. Okay, so which means more continuous conjugation, more is the number of resonating structure, more is the stability. So C is more stable. Okay, so C is more stable. After that B, because at least one cross conjugation is present. Okay, so B, and there is no conjugation itself in the A, so which means it is least stable. So which one is more stable? So C, B, A. So your option number 2 will be perfect answer for this question. Yeah. Next. Tell me the correct basicity order of the given compounds. Which is more basic here? Which is more basic in the given 4 options? Yeah. Look at here. Basic nature in the case of amines or nitrogen derivatives are just because of lone pair electrons present on this nitrogen atom. Okay. So if these lone pair electrons are ready to accept H plus ion, then we can say that given compound is more basic. Okay, so now in the given options, where do we have that lone pair electrons? Here on each of the nitrogens we have lone pair electrons like this. But you know, if these electrons are involving in the conjugation like this, then they are not free to accept a proton from outside, therefore these are less basic. So B is less basic here. Okay, and here see, in the option C, the lone pair electrons are free here, they are ready to accept a H plus ion whenever we show it a H plus ion. So which is more basic here? So C is more basic here. And between A, B, D, I told you B is least basic. And between A and D, how can you decide? See here, these lone pair electrons are present on sp2 carbon, here also on sp2 nitrogen, nitrogen. But you know, these electrons, when they push this side, see, when they push this side, so it can be having more electron density now, right now. So it means it can easily donate lone pair electrons to a proton, like it can accept a good base here. So now this is the next basic compound I am writing here, and after this A, so this will be your order BADC. So BADC, first option BADC. So first option will be your answer for this question, right? Yeah. Next. Let me give you one more question here. So try to solve this question and tell me answer in the comment box for this as a homework questions. I am giving few questions for your practice purpose. So just try this question and tell me answer for this in the chat box. And this one also assertion reason based question, and then next this one. So these are the three questions I am mentioning for you, A, B, C. Yeah, these three questions. Tell me the order of basicity of the given amines, aniline derivatives. Okay, yeah. So these three questions I am expecting answer from you in the comment box. So thank you for watching. Stay connected with this NEET World channel so that you can get daily updates from us regarding the classes and all, and you can get very conceptual classes from our side, a quality classes from our side. Okay, and you can make your preparation to the next level. Okay, so stay connected with us. If you are new to this channel, just click on the subscribe button, and also you can join our Telegram group from the link provided in the description box. Thank you.